Hello, everyone, and welcome to a new EESSI Happy Hour session every Monday between 2 and 3. And today we're starting a new topic series, a peek inside EESSI layers. And today's session is about EESSI design overview. Just a quick highlight for what we covered in the past topic series. It was about how to gain access to EESSI. For today's happy hour session highlights. First, we have a draft blog post for easy on HPE with Cray and Slingshot 11. So HPE Cray is HPE's line of supercomputers based on Cray technology. Slingshot is the networking technology interconnect developed by HPE Cray, and it connects all the compute nodes and storage together inside a supercomputer. And Slingshot 11 is the latest generation, offering high speed and low latency with support for both HPC and AI workloads. So what is special about this is that HPE with Cray Slingshot uses the Cray Ampage as an MPI, which is based on libfabric as the low-level communication layer. And Easy uses OpenMPI as an MPI for the software stack. So the blog gives a short description of how to build OpenMPI on top of Easy on the Cray system, and then use the host injections to inject the OpenMPI library into Easy. So then Easy is supposed to perform on the HPE Cray with Slingshot 11, same as it does on other systems. So for more information about this, you can check the draft blog post, and more about this will come with other blog posts or newsletters. Second point about today is a hackathon session in the wake of Euro HPC User Days 2025. That is Thursday, 2nd of October. We have few more seats left, and you can also attend the session online. For more about this, you can scan the QR code available on screen and join the EESSI Hackathon, either personally or remotely. The third point for today is the easy concept inspiration. So, where did the easy idea come from? The easy concept is heavily inspired by the Digital Research Alliance of Canada, formerly known as Compute Canada Software Stack, which is a shared software stack used on all major national systems in Canada. Compute Canada primarily targeted x86-64, that is Intel and AMD CPUs. They originally used NICs to manage this and later moved toward a Gen 2 prefix-based approach. While Easy is significantly more ambitious in its goals. Easy is set up to be a community project by setting up services and infrastructure to automate the software build and installation process as much as possible, providing extensive documentation and support to end users, user support teams, and system administrators who want to employ Easy, and allowing contributors to propose additions to the software stack. The idea behind Easy grew out of several long-standing challenges in HPC, research computing, and scientific software deployment. First, redundant effort everywhere, especially with the rapid expansion of computational science beyond traditional domains like physics and computational chemistry, including bioinformatics, machine learning, and artificial intelligence, which leads to a significant growth of the software stack that is used for running scientific workloads. So every HPC cluster, university cluster, or research group needs to build and maintain nearly the same scientific software stacks, often repeating the same painful build and dependency work. Second is portability. Software that works on one system, example, a CPU on Linux, often doesn't work elsewhere, example, on ARM CPUs with different Linux distribution. A problem amplified by increasing diversity of system architectures and the growth of commercial cloud infrastructures. And third is limited manpower that is available in the HPC user support teams that are responsible for helping scientists and scientific software users with running the software they require on the high-end and complex infrastructure like supercomputers and beyond. So the main goal of EESSI is to provide a collection of scientific software installations that work across a wide range of different platforms, including HPC clusters, cloud infrastructure, personal workstations and laptops, without making compromises on the performance of the software. That is delivering software that is optimized for the CPU microarchitecture you are running on. Here we can see the different layers of EESSI. The host operating system still provides a couple of things like drivers for the network and GPU, support for shared file systems like GPFS and Lustre, a resource manager like Slurm, and so on. The bottom layer is the file system layer, which is responsible for distributing the software across clients. The file system layer uses CERN VMFS to distribute the EESSI software stack to client systems. CERN VMFS is a mature open source software project that was created to distribute software installations worldwide reliably and efficiently in a scalable way. As such, it aligns very well with the goals of EESSI. Please interrupt me and ask your questions on the chat whenever you feel like there is something I need to further clarify. The CERN-VMFS repository for EESSI is /cvmfs/software.easy.io, which is part of the default CERN-VMFS configuration since November 2023. It is also good to mention that we have covered installing and configuring CERN-VMFS in the first EESSI Happy Hour session and during other webinars and events, so you can find more about this in the EESSI docs. The middle layer is the compatibility layer of EESSI, which levels the ground across different versions of Linux client systems that uses the software installations provided by EESSI. It consists of a limited set of libraries and tools that are installed in a non-standard file system location called a prefix, which were built from source for the supported CPU families using Gentoo prefix. The installation path of the EESSI compatibility layer corresponds to the compat subdirectory of a specific version of EESSI, like EESSI 2023.06 and lately EESSI 2025.06 in the EESSI CERN VMFS repository, which is specific to a particular CPU family, example the x86-64 and the R64. And finally, the top layer of EESSI is called the software layer, which contains the actual scientific software applications and their dependencies. It uses EasyBuild to install software which automatically generates environment module files, which are small Lua scripts that are consumed via L mode. A modern implementation of the concept of environment modules, which provides a user-friendly interface to end users of EESSI. The EESSI software layer also uses RSpec, a small Python library that is invoked during the EESSI initialization script. Also, other tools like Reframe is used for testing the software that is built in EESSI. For more information about the compat and the software layer, we will be having a deeper look in this in the upcoming session. So this is for today. It's about a highlight of how Easy started, what are different layers of Easy, and hoping that on the upcoming sessions we will be diving deeper in the compat and the software layer of Easy. I would like to remind you that the session is recorded, and if anyone has any concern with this, we can stop the recording in a minute or two, and you can be more freely asking and interacting with your questions. Also, just a reminder that although we have a topic series and a session topic, but you can ask whatever questions related to Easy, and we can help you to further solve or discuss or share ideas about Easy.
So going forward, Richard, we're going to peel this apart in a bit more detail, I guess.
Yes, yes.
Starting from the bottom file system layer and then going up, or
The file system layer, we will not be discussing it deeply. We will be focusing on the compat layer and the file system layer. But in
software layer.
case, yeah, in case anyone is interested in having more information, please reach us on the support or on the channel, on Slack channel, or even on the chat here, and we can further discuss the file system layer deeply if needed. Yes.
I guess that would be interesting because certain VMFS is still new to many people, even the concept of what it does. So we can probably like step by step explain how it works and why it makes sense for easy as well. I'm not saying that should be the next session, but it
Yeah.
could perhaps be helpful to people as well.
Like you said, it is important, and we have already covered the process of installing CernVMFS in the first session,
Yeah.
but it is just a small portion of what CernVMFS is. So if more information is needed, then definitely we can go deeper, and maybe we can ask CernVMFS experts to assist in this. There is a question from Thomas. Why do you need three layers? How do you know what you put into each of these layers? So basically, why do we need three layers? The first layer, as we said, is the file system layer, is to distribute the software. The second is the compat layer, which is like to have a common operating system for easy, regardless of which Linux or system we're using. And the third is the software layer, where every scientific software that is optimized for a specific architecture is built, is set. And as we said, we will go deeper into the compat and the software layer in upcoming sessions.
You could even to some extent say there's more layers than that, right? The software layer is actually a set of separate software
Right.
stacks
Yeah.
for specific CPU, whether you call that a layer or not. But yeah, there's layers going on all over the place.
Mhm.
We need to make sure that what the software installations that we provide actually work on any Linux system. So there's a lot of challenges into how you get that software to that system, which may be a system that doesn't have access to the internet. You don't know which Linux distribution is running. It may be something very old, like CentOS 7, or something very new, like latest Ubuntu, or even Arch Linux, or any of these fancy Linux distributions. So that by breaking it down into layers and giving each layer their own responsibility, it becomes a bit more manageable.
Yes.
And really, this is very much inspired by what Compute Canada has done. So they sort of came up with this design, like Richard mentioned, found it to be working well, and we essentially looked at what they did, and we did expand it a bit because they're still, I think, only focused on x86. We pulled it open to ARM and are even looking into RISC-V CPUs already. So you could say that's an extra layer on top where we have three CPU families rather than just one. But it's really very much inspired by what the Canadians have done. Yeah.
And a further question from Thomas, how are you making sure that you're not dependent on kernel versions?
That's also a good question. We're trying to pay attention to that. Now, it is actually when you're only building user-facing software, it's not that you won't quickly get tied down into kernel-related stuff or kernel API. But we do have some applications like Qt5, for example, where we need to pay some attention. So they are at least looking at the kernel headers, looking at the API of the kernel, and some stuff may slip in there that is specific to a particular kernel. Right now, we haven't seen any problems there where people are running a too old or too new kernel. And frankly, I'm not even sure we're paying enough attention to that. But generally speaking, those are definitely the exceptions when you're talking end user software or software applications. That those would be talking to the kernel directly. That's rather rare. This is usually done by glibc, for example. And the applications just talk to glibc, so you already have a layer in the middle. Does that answer your question, Thomas? We're already asking ChatGPT to help you out with questions. They are good questions, so yeah.
Any other questions from the attendees?
And again, like Richard already mentioned, they don't have to be on topic, right? If you have any other questions, they are definitely welcome at each of the happy hours. Anything that's unclear or any aspect that you're unhappy with is definitely up for discussion here.
I already introduced Faustin. Oh, we have another question. What kind of drinks do we get in the happy hours? You can get water, you can get juice. It's based.
No. Bring your own drink.
Bring your own drink, yeah. For some reason.
Yeah, I'm not sure, Faustin, if you want to explain
Yeah.
a bit more what you're using Easy for. If you want to do that on recording, off recording, it's up to you. But
Faustin, would you like to stop the recording and then introduce yourself again and with better where you're using Easy and what you're using Easy for, or it's okay if we continue the recording?
No, it's okay. It's for me, it's okay. Whatever.
So
Can I start?
again, yeah. So
I'm using Easy for on both Roku HPC and also in Anoris.
maybe you can introduce yourself again, Faustin. Sorry, in the beginning it was not recorded. So since you want to now share your experience in that, maybe it's good to mention about yourself a bit and then explain where you're using Easy.
Yeah, thank you. My name is Faustin. I work at UIB in Scientific Computing Group, and I'm in charge of servers for Geophysics Institute, and I'm also part of the infra team in ANARIS, which is the National Infrastructure Research Services that takes care of like this HPC, national HPC, and provide both the service and the resources to users. Mostly using EESSI in Roku HPC, which is currently NREC, and NREC is a cloud with many instances, normally VMs, and I'm using Easy on those instances as the main software stack. And on top of that, I install some software which are not part of the Easy. And for instance, we have 3 servers. 2 are normal server, whereas one of them is a GPU node. And both of them I use same EC mounted. And on top of that, I install additional software on top of Easy on a separate NetApp volume, which is shared on all those three nodes. So yeah, and yeah, the other part that I use EESSI is on NIRD.
Mm-hmm.
Yeah, where
So you're
I
using easy on different like infrastructure, and it basically is simplifying things. You can run the same software on different systems.
yes. And the challenge is the only challenge is when, for example, I had to install some software or the software that
Mhm.
required the toolchain that EC does not support. And then in that case, I'm trying to build that using the new toolchain.
Can you
Uh,
specify, Faustin, which toolchain are we talking about? Maybe it's good to share with others. Maybe they're having the same issues. So
uh,
is it a new toolchain or older toolchains, you mean?
for instance, it's two parts. For example, if I'm going to build NetCDF, which is old, because some of the users were using these old servers with all the software that they installed like 5 years ago, and then they want still to use the same software. But if I have to them on new NREC instance, then both the architecture and the distribution is different,
Mm-hmm.
and it's hard to keep the existing or the old software there. So when I'm talking about old, then for example, if I want to install it, it's not a part of the toolchain that are supported already with AC, and
I believe
that's
you're
not a,
talking about toolchain 2021A, right?
yes, like
Yeah.
that's for example toolchain 2021A, or
Mhm.
some of them they use also toolchain 2018, and
Oh,
it's
yeah.
very old. And yeah, for example, if they want to try Panoply, for example,
Yeah.
so it's definitely require this old toolchain that is not supported with EC.
hmm
But there is possibility also to build it using new toolchain, and
And I
yeah,
believe
it's
you are already using our new tool chains before even we like make the whole tool chain available, right?
yes. For some other software also, I use this toolchain 2025.
Yeah.
So yeah, at least I tried for some few software, and it worked out.
hmm
Yeah.
So
So
this is interesting because especially for 2025A toolchain that we're still looking into, we're trying to build that on top of the 2025.06
Yeah.
version of Easy, and we're hitting some problems there. So can you explain where you were using this toolchain? Was it with the new version of Easy or let's say the previous version of Easy,
Uh, I,
23?
I had a quick look with Faustin on this. So basically, he's using the GCC from both 2024A and 2025A. He's not still using the whole tool chain with the MPI,
Ah,
but he's
okay.
using the
yeah,
GCCs available
yes,
there. Yeah.
yes, exactly. That's what I was going to mention. I'm not like using MPI or this other uh, toolchain, but I was like trying using GCC for like
All
2024
right.
and
Okay, okay.
2025. So
Yeah.
I didn't try using like MPI. I don't know if you have already experience with like ongoing issues so that I don't lose time trying it. So
Well, so for 24A, the only issue, it's actually a change that we need to make or want to make. We want to make sure that we provide an open API that supports IP version 6, not only IP version 4. So it's a very small change actually that we need to do in our hooks to enable that feature when we build OpenAPI. So there we don't expect any big issues. For 2025A, so for one of the latest toolchains that EasyBuild supports, we're seeing a very weird problem with building Python because we're going to Python 3.13 in that toolchain, which is quite recent, where they do some profile guided optimization during the build of Python. So they're essentially running tests with Python itself and feeding how fast those tests are back into the compiler, so it can do a better job of optimizing the Python installation. And somehow that's going wrong when that happens inside of the easy build environment. So Python with the 25A toolchain is currently, there's a real build problem there, right? We need to figure out. For 24A, it should be fine. Even there, you could build your own MPI already and start playing around with things if you're impatient. But very soon, we should be able to provide the OpenMPI installation in there.
Okay. But with Python, if you precise like Python 3.12, that shouldn't be a problem, or?
Yeah. No,
Okay.
3.12, I think, is already installed in EESSI 2025.06.
Okay. Yeah.
Yeah, it's Python 3.13 that's a problem for the 25A toolchain.
Okay.
Well, yeah, hopefully we'll fix that soon. I've spent several hours on trying to figure out what goes wrong there. It's not clear to me yet.
Yeah. So, and some other challenge that I was encountering is when, for example, I'm trying to build using all the software using new toolchain. It always has to fetch from like EESSI. If I have this local software that I have built on top of EESSI, sometimes it doesn't work there. It doesn't like go there. So yeah, I still have like to direct it, even though the path to those toolchain is already in the path, in the model path. But yeah, well, I usually like to have some challenges there, but at least now I would say that I'm managing to build on top of EESSI, and few challenges is possible like to be solved. I most of the time disturb Richard for like some few issues that I encounter in the way.
If you're seeing puzzling things that you're not sure why they are happening or that you think should be working but are not, let us know. And the best way, maybe Richard, you can show this, is going through the support portal that we have.
Yes.
We actually have this in our website. You can open a support ticket, which, I mean, this is a free service that we offer for anyone who wants to use EESSI. You can report any problems or ask any questions, and we'll do what we can to answer them.
And feel free to post them on Mondays in EESSI Happy Hour sessions. So if you face anything that you see that it's like a bit hard, a challenge for you, you need some assistance, it shouldn't behave that way. So share it with us on Monday sessions. We can definitely help you with that.
Yeah, sure. The issue. Do you have like a separate channel for EESSI? I'm just trying to locate where.
Maybe go to the website, Richard, and show him the link for the Slack channel and also the link to the support that we have. Yeah, this link will work. It's better to go to eeessi.io, so the main website.
Yeah. So you can find the EESSI Slack channel link in the documentation.
Yeah. Or if you go change the tutorials part in your URL, Richard, just change it to support. Yeah, and the stuff behind it as well.
I guess I'm in now.
Yeah, so the Slack channel is easy to join. Also here, this is support portal. So you can either send an email to support@eeessi.io, that will open a ticket on our end, or you could go to the GitLab link on that page there as well. So the Slack channel is useful to just have some quick back and forth with somebody who's experienced with EESSI. The support channel is to actually get something documented. Let's say if you had a problem and we figured out a solution and we think this could be relevant for other people, then it would be good to start a support issue on that and explain. Yeah, so we can just provide an answer in there that it stays there. All the discussions in Slack are temporary. Let's say they will disappear over time. The stuff in the support channel will stay. Yeah. So there's actually multiple ways of getting help. Slack is a very good one. These happy hours as well. If you can wait a bit until you get an answer, or to look into something interactively. That's something I think we can also do in the scope of these sessions here if there's time. And a bit more structured is then the support portal where you can ask questions just via email or by opening an issue in GitLab. So there's many different ways of getting help, and yeah, whatever makes most sense to you. Depends a bit on how urgent it is or how much back and forth will be necessary to make things clear.
Like our colleague Faustin is maybe from the first users who are already trying the new 2025.06.
Yeah.
He is also using the extend module and he's building on top of what's already available. Yeah.
Yeah, that's very interesting to hear experience, let's say, the user experience from these early adopters, because there's probably some rough edges that we no longer see because we're so used to how things are the way they are, and we know our way around the problems if there are any problems. But for people like you who are more outside of the project, it's very interesting for us to get your feedback and see what's working, what's not working, what can be improved, and so on. Yeah. So if you're joining the Slack, that's very, very helpful. And you'll see if you ask already. Yeah, you'll see if you ask questions there, you get quick feedback as well.
Yeah. Thank you. So yeah, I think that's it on my side. So
great. So for now, I will stop the recording in case anyone wants to share anything with us without being recorded.